Hello and welcome. This is Mr. T. Thank you for tuning in. It's always a joy to have you. You're watching video number 4 in the video edition on Analytical Geometry, grade 12. And in today's video, we're paying a special attention on how to calculate the radius and the center of any circle which is not in its standard form. In other words, we are looking at a circle that comes in the expanded form. The prior knowledge that you require for you to be able to answer the examples that we've given you or that I'm going to give you is the knowledge on completion of the square. So we're going to look at the first example, which reads as follows. Determine the center and radius of the following circles. Part A. You're given a circle with the equation x squared minus 2x plus y squared plus 4y minus 16 is equal to 0. So in order for us to do that, we need to complete the square in terms of x. I'm reiterating, complete the square in terms of y as well. If you do it correctly, you're going to get x squared minus 2x plus minus 1 squared plus y squared plus 4y plus 2 squared, and that is equal to 16 plus negative 1 squared plus 2 squared. Thereafter, we need to simplify that further, knowing that, or having realized that the first three terms now, in terms of x, the first three terms in that light blue color form a perfect square, and that is also true for the terms associated with y, the one that I'm underlining. So we're going to get now a new expression written as x minus 1, all that squared, plus y plus 2, again, all that squared is equals to 21. If you look at the equation that we have now, it's now in its standard form. We can easily identify that our radius is equals to square root of 21, and our center is made up of the coordinates 1 is to negative 2. At any stage, should you need to fully understand it, feel free to pause the video, then just press play. I move on to the second question. You're given 3x squared plus 6x plus 3y squared minus 18y plus 12 is equals to 0. Notice your coefficient of x squared and the coefficient of y squared is not 1. We always want the coefficient of x squared and y squared to be 1. But this time around, the coefficient is 3 respectively. So we need to divide each term by that 3, and that will result in x squared plus 2x plus y squared minus 6y plus 4, and that is equal to 0. Thereafter, we repeat the same process of completing the square in terms of x and y respectively. And if we do that, we get x squared plus 2x plus 1 squared plus y minus 6y plus negative 3 squared, and that is equal to negative 4 plus 1 squared plus negative 3 squared. Thereafter, we notice that the first three terms in terms of x, again, they are a perfect square. They form a perfect square. That is also true with respect to y as well. So resulting in the following expression, x plus 1 in the first bracket, all that squared, and in the second bracket we get y minus 3, all that squared, and on the right hand side we get 6. Again, this is now in standard form, which is what we want. Now the radius there, we say r squared is equals to 6. Therefore, our r is equals to the square root of 6. So our radius is root 6. Our center, though, becomes negative 1 is to positive 3. I hope you fully understood that and you've enjoyed. Continue watching. Bye-bye.